Hello, everyone, and welcome to Passive House Accelerator Live, where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to the impacts of climate change. I'm Zach Semke, Director of Passive House Accelerator, and we are super excited to welcome Sarah Kudra and Rand Lemley to present about Kenzi, Sizzling All Electric. Our co-hosts for today's construction tech episode of Passive House Accelerator Live are Ilka Cassidy, Mark Willey, and Shannon Pendleton. With that, Shannon, please take it away.
Thanks, Zach. Hi, Accelerator friends. Welcome to Passive House Accelerator Live. I hope your projects are springing up out of the ground and getting ready to pop. I'm Shannon Pendleton, Principal at Sanderson Sustainable Design and Source 2050's material expert. And I'm excited for today's presentation and a really refreshing focus from global events to the Hippocratic Oath and how profit and scale don't need to outweigh people, sustainability, and our safeguards for well-being. So let's build that future together today. I'm going to hand it off to Mark Willey. Hi, Mark.
Hey there, Shannon, and I like that oath. My name is Mark Willey. I'm always excited for what comes over for everyone to enjoy on Passive House Accelerator, right? The technical, the technique, and the technology. And I have a little favor to ask of everyone. In a few days after this airs, this gets published. And there's a few folks that didn't get to make this meeting. All the joyful faces in the crowd here, please go ahead and share this presentation with your network and include Sarah and Julie and Rand and their voices so that others that didn't make this can spend the time on Sunday diving all in or whatever night they have free. Thank you for joining us. Over to you, Ilka.
Awesome. Thank you, Mark. And such a good point. And these videos are such a good resource to just go in and watch at a later point. Yeah, I'm really excited to be here today and to learn about the Sizzling Kenzi. And well, I'm Ilka Cassidy and I'm with Holzraum System, and I'm also the co-host of the Passive House Accelerator podcast, another really good resource. And I have the honor to introduce the speakers today. So there's Sarah. She is the founder of Architecture Towards Neutral, a new firm committed to radically transparent practices that aim to bend the global emissions curve toward neutrality. A registered architect and NCARB certified professional, she holds dual degrees in fine arts and architecture from RISD. With deep experience in affordable housing, including her time as Affordable Housing Director at Dream Collaborative, Sarah is also a CPHC and BPI building analyst, passionate about housing affordability and environmental justice. Rand, AIA CPHC, is a project architect and sustainability lead at Dream Collaborative, where he focuses on the intersections of design, justice, and the environment. His work spans high-performance affordable housing, energy-efficient detailing, and decarceration design, all grounded in the belief that design justice is environmental justice is social justice. Rand is a licensed architect in Massachusetts and New York, co-chairs the Decarbonizing Existing Buildings Alliance, and teaches at the Boston Architectural College. So welcome, Sarah and Rand, and thanks for sharing your knowledge with all of us today. So yeah, please take it away.
Right. Thank you, Ilka. Thanks to everyone at the Passive House Accelerator for having us on. This is a really exciting project. We're so glad to be able to share it with folks. And despite having shared a couple other venues, we've never had a recording of it. So this will be a really fantastic opportunity to have it shared more broadly. And as Mark said, like and subscribe, right? And then Bev Craig of Mass CEC, who connected us to the opportunity. So we're here today talking about the Kenzi. We named it Sizzling All Electric because Massachusetts has got a lot going on. We're in Boston right now, and this project is one of a whole wave that are coming up. But we were the only, and are currently the only, with an emergency backup battery system. And so that's what we'll be kind of focusing on in the context of Passive House, which is really what made that possible. So click. That was our fun little emoji we used like on Slack when we were talking. Rand and I were former colleagues, and so that's where this project was built with Dream Collaborative. I am now the founder and principal of Architecture Toward Neutral, and as you heard in the bio, working to decarbonize the built environment. Rand?
Yeah, and I'm Rand Lemley. I'm project architect and sustainability lead over at Dream Collaborative. Like Sarah said, you're pretty close colleagues, and hoping to continue working together on projects into the future.
All right, so the Kenzi is this beautiful project. It's located in Roxbury, Massachusetts. We'll show you a map in a minute so that we can kind of understand where that is more geographically. But folks are always talking about decarbonizing, and we're going all electric, and we usually use that to mean the systems of the building. But when you hit a certain size threshold, here it's 4 stories or above, you have to have emergency power backup. That's for the life safety systems like fire alarm panel, lighting, elevators, and fire pump if you were to have one, right, for sprinklers. And so in those situations, it's the default to use a diesel generator on site and store that fuel on site. And so we had the opportunity of working with Preservation of Affordable Housing to change that paradigm and to think about utilizing electric for backup also. And it is PV tied and grid tied. We'll get into the details. So it's a really wonderful system that does a lot more than just the backup emergency power.
Yeah, so a little bit about Dream Collaborative. As a firm, we're minority owned, been around for about 16 years. We've got between 15 and 20 employees, over half of which are women, which is fairly uncommon in our profession. And our goal is really to create beautiful, authentic places and enable better outcomes for everyone involved. Signatories to the AA 2030 commitment toward zero carbon by 2030 in all our designs, and just really proud of the work that we do with and for people.
And Dream is pretty close to that. Architecture Toward Neutral is hitting that spot because I'm building 0 square footage this year. Hooray! So I think it's one of those things. We're moving toward all of that in our practice as we start to work on decarbonizing buildings, which is its own challenge. Focusing on things that are a lot of source energy, thinking about all electric as it pertains to the emergency side of things as well. Thinking about carbon reduction, embodied carbon reduction through the use of bio-based materials as the kind of primary palette of the work. And always considering passive house, right? I think that we all understand that's really the kind of going standard for very high performance work right now. All right, Rand.
Yeah, so the first question that we start with is why here, and why specifically this neighborhood, and why this type of project. We see sustainability as a human-centered concept. The planet's going to be just fine without us. We're not trying to save the planet. We're really trying to save our way of life. And toward that, we're thinking about the ways in which we can sustain the people that are on the margins. And the federal government has this definition of an environmental justice community that is related to heavily high prevalence of minority, high prevalence of low income, and a high prevalence of English isolation, which is like English as a second language. And the map of Boston that we see here is hitting 1, 2, or all 3 of those. So the blue spaces, the blue tracks from the census are hitting all 3 of those. And this project happens to be in one of those tracks that hits all 3. So this is truly an environmental justice community. The site for this project is located at Bartlett Station in Roxbury, which is a neighborhood in Boston, predominantly immigrant community and Black community, rich history. And the site is a part of an overall master plan that used to be a MBTA bus yard. So MBTA is our public transit around here. And this used to be a heavy brownfield site with a lot of disgusting bus fluids on the ground. And about, say, 15 years ago, local CDC purchased the parcel and has been putting together a master plan. That master plan is 9 buildings that come up to 360 units in total. Our project is one of those and is the only project that POA is involved in, and really transformative for this neighborhood.
You can tell because it's the most beautiful project. I'm not biased at all. So building systems, you know, when we talk about all electric, like I've already said, we think about the building systems, but we really have to kind of like break that down into each thing and how all of those are interacting. So first, we super insulate, right? These are passive house principles you are all very familiar with. Multifamily is kind of a nice size to be going passive house because of the density of units. So you have a lot of units with a relatively low surface area. So it means you don't actually have to make a wildly thick wall like you would in a single family. So here we just have an R35 wall assembly, an R60 roof with we have cavity insulation, mineral wool, and continuous rigid mineral insulation on the exterior between fiberglass girts. Air tightness, super critical. So here's our little airtight boundary. That's our passive house boundary. 0.6 of a CFM per square foot per envelope area. I think that actually is where we tested, right? You know, we have to hit some of these numbers. So now the project's complete, we can say we actually were there. In regard to part of the way we can meet that challenge is by having a pretty minimal amount of glazing. It feels really large. The units live large because the windows are wide. They're 5 feet wide, 6 feet tall, but we've lifted them up off the ground to the sill height of 2 feet, which is a little antithetical to a kind of modern unit design. You see glass going to the floor and then everybody has to hide it with their furniture, you know, block it up somehow. But what that did is it left us with only 19% of the walls are glazed, and that 77% there is performing at this much higher level. And so the other part of what you see here in the diagram is we're excluding the garage. The building is earth bermed. We'll get into that a little more. So the garage is effectively our basement, except for where the units and the lobby touch down in the front of the building. And so that is included in the boundary, and then the garage is excluded. And you can see we've done that. We insulate then the roof, the ceiling of the garage between the unit and the garage. And what we did then when we touch grade at this smaller footprint is we use this really fantastic product, which folks, I believe they're a sponsor of Passive House Accelerator, folks might know about, but this is Glavel. So Glavel, no, I didn't stutter. It is glass aggregate. It is also taking the place of a structural gravel fill. And so it's this really wonderful product that kills 2 birds with 1 stone and works as the subslab layer. And it excludes then, you do not need the stone, you do not need the foam. And so it's a lower embodied carbon because it's a primarily recycled product. And we have wonderful feedback from the contractor that they love this and they'll always be using it moving forward. We had a snafu in bidding. They didn't understand that it was this weird product with this special name. They thought it was a typo. And so they priced in the kind of standard system, right? So you think about stone is one contractor, foam is another. And those 2 trades end up being more expensive together than the use of the Glavel as one trade coming through, implemented by the GC, you know. And so we've converted at least 1 contractor in the process. Oh, so I went on about it, but here's the really fun install. So it gets dropped off by big dump trucks. It makes this big mountain of fun, fluffy gravel on the site. And then here you can see it getting installed. So goes in, gets compacted in lifts, kind of standard system. Rand, do you recall how many inches deep we ended up? 10-ish?
We were 18 inches here. So it was in 3 lifts.
Yeah, awesome. And then on the top right, you can see that we do it similar to how you do other subslab, it's continues outside the thermal envelope to kind of buffer that. So that photograph is being taken from inside the garage, which is unconditioned space, and the gravel is seeping out below the slab of the conditioned space on the right of that picture. Okay, so electrified systems, we have heat pump hot water. Those are located in a semi-decentralized way. We actually have kind of a little plant that Rand's going to talk about how that functions. But it's floor by floor, so many smaller kind of residential scale tanks on every floor of the building. It does have a recirculation loop. We didn't quite hit our distances. I mean, need it to be said, it's all the low flow fixtures we use for EPA, water sense, etc. For ventilation, there's 2 ERVs on every level, energy recovery ventilator. And this was kind of the happy medium of equipment scale because it allows the maintenance to be done from the corridor side, so you don't have to interrupt tenants versus having a unit in every an ERV in every residential unit. Then you have a lot more kind of coordination for the maintenance. But it does offer a little bit more redundancy the way unit by unit ERVs would by having it on every floor, by having 2 in each location. You get to do some maintenance and you can shut down pieces of the system without the entire building having to go offline for maintenance. So where if you had a centralized rooftop system, you wouldn't have as much flexibility. So it kind of was that happy medium. They vent out the facade. And then we have on the roof, there's a centralized VRF system going into each of the units. All of the units have their own controls. You have heating and cooling simultaneously. And this again was a decision by the owner. They pay for the utilities. Part of the value to POA as a long-term building owner is that they are directly seeing the benefit of the performance of these projects. And so by having the central system, they can right size that equipment, where it's very hard again to find equipment that's a small enough BTU per unit when we're passive house, because we're using such small amounts of energy. So here's the ERV in the laundry room location under construction. Here's what those VRFs look like daisy chained up on the roof. And here is the hot water closet that Rand is gonna tell us about.
Yeah, so in the diagram that Sarah was showing, you may have seen the blue rectangles kind of scattered along a corridor. That was the initial idea. What actually happened in practice was we found that even if we distributed things through the hallways, we weren't quite getting close enough to the point of use to meet the passive house requirement for volume within the plumbing. We see around here that we need to get within about 25 feet because of the plumbing code. We couldn't do that. And so what we did is we got a couple of closets, a kind of catty corner to each other across the corridor. We were able to put the 4 heat pump hot water heaters distributed 2 each in those closets. And then we have a recirculation loop per floor for the water with an aquastat on the return side, just measuring the temperature of the water, making sure that it's still at the design spec. And then we have a mixing valve on the hot water side directly next to the tanks to make sure that if the water temp does get low, it can feed some more hot water back into that system. This was a little bit funky because we have 2 closets that are remote from each other that are both feeding the same recirc loop. So we had to pipe up and over our corridor to get to the aquastat and the mixing valve, but it's working completely as intended.
Awesome. And so here we have an aerial taken just before the project was complete. The plaza's not done yet in this picture. And so on the site, we have kind of the bells and whistles. There are EV charging stations in the garage. We have beautiful walking paths that connect different streets to the community and to get to transit. And here is the full spectrum of the PV array. So What we did was worked with our PV vendor, Revision Energy, carefully to try to coordinate where our plumbing stacks go, right? This is the Achilles heel of rooftop array installations. And it's really hard to get all of our trades kind of on the same page. And if that plumbing pipe had only been a ½ inch over, we could have fit another panel. So I think we did a pretty darn good job ending up with, I think we were about a 65 kilowatt array in total at the end here. And you can see the VRFs again on the top. Those things are enormous. So the design of the building was kind of meant to mimic the topography of the site, but it also works very well as an incredibly tall screen for incredibly tall equipment. So the battery system allows us to take charge of the energy generation and do some demand offset. So by being grid tied, by having the array, we can utilize maximum production times for grid buyback. And the project is likely to overproduce in the summer, obviously in the northern latitudes. And it can really help us offset the efficiency with the VRF for cooling. And then in the winter, we might have to draw a little bit more from the grid as that higher demand is being asked at the nighttime for the heating use. But we often, when we're talking about electrifying, we're forgetting about the fact that we need to use the battery systems. And so, or we forget about what the backup would be. And so we'll get into that. Right after this beautiful interlude, this is a big part of the environmental justice component of this work. Because we were earth bermed, because it was that transit station, we had like about 25 feet of elevation change from the back of the site to the front. So we found that as an opportunity to put the garage below grade, still maintain units up front. So we had a kind of street presence that was active and lively, as the city loves to see and as people love to see. But we also managed to get this really nice roof terrace, which is now basically, it feels as if it's terra firma. It's part of the landscape. It overlooks a future plaza that's going to be a kind of program space for the site. Okay, so we decided to switch to a battery in the middle of our construction. Would not recommend doing that if you're interested in going down this path. But what that meant is we had to seek a permit amendment. And so there were a lot of questions that the Boston Fire Department and Inspection Services Department had for us, as this is literally the first time they were dealing with this, the first folks who were crazy enough to go and ask about it. And I think that the questions were all very justified, right? These are things that the first responders have to interact with, that they need to know how to manage a technology that is new to them, right? That we've been living with diesel generators forever. It's a known quantity versus how do you kind of deal with this new system? It kind of seems, it's more of a black box, if you will. And so that's really what brought us into this bigger conversation with a code consultant and a lot of communication between all the parties involved. So this image, you can see at the back, is a set of kind of utility double doors. That's our battery space. So the really beautiful thing about this is that the piece of the building that we're looking at, where the battery is currently located, was originally designed to be the diesel storage room, so the diesel fuel storage. Because when we permitted the project, the generator was going to be on the roof. You can't store the fuel on the roof because it's highly flammable and noxious material, and it can't be on your building. So there's like a real irony that we're allowed to do that by right in the code, but this kind of clean tech is still something that folks are very fearful of. So it's always worth kind of reflecting on that to people when they're giving you a lot of pushback about it. But here we're going to work our way outside in, and basically, because it was going to be a diesel storage space, it was a 3-hour rated room. It's constructed of CMU and cast in place concrete. It's outside the footprint of the building because of the topography of the site. We had that luxury here. It is fully conditioned, and it has a double interlock pre-action fire suppression system, which is to say it's pressurized. So if the fire suppression is triggered, you get a buttload of water all really fast at once. And that is necessary. We are working with a lithium ion composition chemistry of the battery. It really would need that true deluge, but it's not going to set on fire. So let's keep that one in mind. It has a lot of backup redundancy. So keep your eye on the column of the canopy right in the middle of the image. There it is under construction. That's the concrete, or excuse me, the CMU kind of going up as it was in construction. And so we changed this like right at the perfect time where we could modify just slightly the dimension of the room. It was almost where it needed to be. But the big difference is that it needed to be taller. So these batteries are housed in fire-safe cabinets. We have 2 cabinets on the job, and they have a deflagration panel on the top. So that's an explosion mitigation tool that starves the fire of oxygen. It like vents it just into the room, not out to get it out of the cabinet. But that's like, again, it's a hat in the way our VRFs are very tall. These things have need a lot of headroom. So we had to crane pick the cabinet into the room before the roof was built around it. So you can maintain and work on these modules without taking the roof off again. Don't worry. All right, so then here's the 2 cabinets, and inside each cabinet, there are racks that contain 17 battery modules. It's a lot like a server rack. And that rack controller is integrated into a building management system, a BMS, that ensures safety. The modules are monitored to make sure they're operating within their programmed range for voltage, current, and temperature. The rack has a fuse to protect the system in case there's the event of a short circuit. And then there are 3 levels of reporting between warnings, alarms, and faults. And that rack relays all of that information to what's called a master BMS. That's controlled by the building automation system. So that's a single point of control for multiple racks in a bank. It has a web-based human machine interface HMI for troubleshooting and configuration. And this is done off-site. Moving to the smaller scale, the battery modules are each designed for safety. The unit has an integrated fan. You can see, again, like a computer has a little fan, right? And that's the hexagonal thing. It's housed in a certified flame-resistant material. It has insulated bus bars, a concealed front panel cover, an integrated module fuse, and they're all wired to monitor voltage and temperature and self-balance. So that's a lot of tech words that I had to do a lot of research about to say the thing's not going to get on fire. It's not going to go up in flames because it's being monitored at a bunch of different levels. But the fire department has that mentality, you know, if you're a hammer, you see a nail type of deal. So we had to really help them walk through all the way this technology is designed. And in case that isn't enough, unlike a lot of these high profile battery fires that we see, these are not a car speeding down a highway, and they're not going to crash into anything. So I'll leave it with that. Am I still talking? Would you like to? I'll go.
You're on a roll.
We're on a roll. People are tired of my voice at this point. Some of the other questions were just like, how close are we to things on site? Because we were part of this master plan, it was not built out. And so there were no other buildings to kind of measure lot line fire separation distances. We did in theory, right? But they wanted to know it again kind of on site. So those buildings are being built out right now. And then we happened to be planted directly in front of a fire hydrant, which was down on the curb on the inside of the new infrastructure. We had great water pressure because it was a new road for the city. So we didn't have to have a fire pump for the sprinkler system at all. And then additionally, because the whole project is earth bermed, like the building where the battery is like halfway underground, right? So in case anything's going on, like it's very isolated. And this little yellow square would represent what this rooftop would look like if we had had a generator on the roof, but we didn't. So we got more panels. So another wonderful reason to move that sort of stuff off-site. This diagram basically is saying in orange, here are the items that we need to talk to each other. So the battery is all the way here on the right in the room. The electrical room for the project is in the center of the garage. and then the transformers all the way over on the left. And that was one of the things the fire department wanted to make sure, is that the transformer and the battery were not too near to each other. Again, in any kind of emergency situation, they didn't want one to cause the other to have a different an emergency as well, right? Like, we'll leave it at that. And then the magenta space in the plan is the community room and the office spaces for the full-time staff that are on site. And this is a building 55 plus age restricted housing, and fully affordable, a mixed bag. I think we have a couple market rate, but very deeply affordable unit. And so because folks are a little bit older, we want to make sure that they have a space where if there is an emergency and the power is out to the rest of the building, this is what we're calling like a shelter in place type of room. And so the community room will be fully conditioned. It has amenities like a refrigerator in case someone has a medication that's sensitive and it needs to be kept at the right temperature, but the power is out. They can come to the community room, they can charge their devices and communicate with loved ones. And so this room, while it is not everybody's living room, it provides a lot of services for folks. As long as that sun is shining, this room is going to be online. And I think we have various different numbers of how much energy, depending on what you're using, the battery system can charge and run these things for a very long time. Okay, code language. The short answer here is there's no current code path to make this happen. It's all kind of a pieced together bunch of information originating from Massachusetts State Code 527 CMR is our fire safety code. Basically, it is NFPA 1. That's the 2015 version. We're coming up to adopt a couple of newer ones, but that version refers to a variety of other code path, different language. 855 is energy storage systems. And so what our code consultant did was clarify and pull the language out of each one of these documents to say, how are we complying to what is the kind of standard of care? And so in the case of an emergency, how is the communication relayed? What is the protection of the room? And we managed to kind of put together, she did, not the architect, but the code consultant, a very comprehensive narrative of how to, what will happen for each of these events. And then that was enough to sort of communicate to the AHJs how the system is going to perform, and ultimately convince them. And we were permitted. Okay, Grant.
Yeah, so as Sarah said, one of the priorities for POA, the client on this project, was taking care of people. So the older residents in this building have this community room with refrigeration for their medicines, in addition to the code required emergency loads. So POA decided to oversize the battery so that they could take care of not just the code required loads, but go like 3 times further than that. So in the case of a full power outage, if there is no sun, this is expected to be able to run for about 15 hours. And the cool thing about being on a battery backup system rather than a diesel or a natural gas generator is that your PV still works. You can still have your PV plugged in and feeding the battery and continue to feed that power. So by switching to an all-electric system rather than using those fossil fuels, we were able to take advantage of that renewable energy, even in the case of an outage. It's pretty critical. One of the cool things about the project is that revision, this is the first time that this has been done. And so Revision Energy did a really good job of helping us educate people in the building about what is actually happening. And so in our entry vestibule, we have this dashboard that's kind of clunky, but it's connected to the dashboard that is on the battery itself. and you can see what the loads are doing in the building. So this was a day I was out a couple of weeks ago, and the loads that we see on the site load, that's not the entire building. That's really just the services connected to the emergency systems. But you can see that the grid is being fed 38 kilowatts of power. Like it's pretty substantial, and pretty exciting to see. And I'll also say that even in the middle of winter, Boston winters get cold. We have snow, we have ice on the roof. Even in the middle of winter, I was out in early January, and snow and ice on the roof, we were still feeding the grid 17 kilowatts. So really impressive job by everyone involved.
It's cool to see the numbers coming in. So I'll give Julie a second to get on mic, hopefully, and tell us a little bit about the financing behind this. It was expensive, but that was kind of a standalone cost, and Mass CEC generously provided some grant money for that. Julie, do you have anything you can add to this?
It was expensive. I think switching midstream, we'd already ordered our generator, and so we didn't get a huge credit back by not taking advantage of it. So these are sort of hard costs. The good thing in Massachusetts is there's renewable energy credits that will help us, that helps incentivize all of our solar arrays in the state. And there are also some demand response costs that we will see now that we have a fully accounted for energy in our building. It took the utility about 6 months to realize that there was one very large house meter up for the building that we weren't getting charged for. So $60,000 bill in January for 12 months. So now that that's all set, we can start reporting the accurate data and start to see some of those incentives come in. I think we're thinking 8 years will pay for this. And I think we always kind of are a little conservative on what our solar can do. So maybe that'll be even better.
Yeah, and 8 years also, we're not talking about all the inflation we're going to be seeing in the delivery and maintenance costs of fossil fuel sources. So I think that's also something that's really exciting about having moved to electric and being at this moment invested in that. We're hoping it's only coming down, right? So a few lessons learned. I'll have Rand, you can start off with some of this. Rand was boots on the ground constructing this. So most of these were Rand's lessons, Rand and Julie's.
Yeah, so going back to early conversations about the ventilation at the point of use in our units, we were using car dampers to keep the ventilation modulated at the correct design pressure. And unfortunately, the car dampers that were installed were not the car dampers that were designed for, and they had a different sensitivity to pressures. And so we had to go through an extensive balancing campaign for these car dampers. And I mean, Passive House already has tight tolerances all over the place, and we had to ratchet those down even further in some places just to get the ventilation at the design pressures. And along with that was kind of resultant from some of the subcontractors not really understanding their role on the project. And the type of project that we were trying to execute is one that is just higher tolerances and more strict requirements. And so as much as we could, we were out having conversations with subcontractors while they were working and just asking, how are you approaching this? How are you approaching that? But we also had pre-training early in the construction process and at milestones throughout the process. So if we knew that in 2 weeks we were going to have the ERVs show up the architectural team and the sustainability consultant would do a little bit of training with the subcontractors to talk them through how that was going to get executed. Our mock-up, for example, went through, I don't know how many iterations with the framers to try and get window detailing correct, and get the membrane rolled on with the correct pressure, because it was just materials that they hadn't been used to using up to that point. So getting that training and getting the mock-ups down correctly is
And
really
I'll
important.
add to that one, Randa. I mean, I think a role of a mock-up is very critical. We talk about that a lot. In Boston, we end up doing that, especially on affordable housing projects, because a lot of the funders are wanting to review materials. And so we have to have this thing kind of to show them what it's going to look like in any case. But to make that a performance mock-up, to have the opportunity to trial some of these is really critical. And it's really funny when you come to the job site and your SIGA self-adhered membranes kind of like flapping in the wind. You're like, someone didn't quite get that right, you know? So you kind of get to watch it as it's happening. And like Rand said, to make sure that everybody understands that, like, yes, it does matter how you put that on. That makes the entire system work together. And we had that with some engineers, a couple of revelatory moments on site where they're like, oh, is that why you wanted me to do that thing? We're like, yeah.
Yeah, so that's also kind of hit the third point here about communicating early and often about the goals of the project. With our general contractor, we did not, at the beginning of the project, have someone identified as the air tightness guy or person going around the site and making sure that things were taken care of. And as they kept getting called out on issues that I was seeing on site, they realized that it was actually more cost effective to just deputize somebody and make them that person to ensure that things were being taken care of on the site, even when I wasn't there. So that's just one example of that communication taking place. And I think that's probably a practice that many of you also advocate for and are trying to get accomplished on your projects. The last point here is a kind of funny one in retrospect. We had in our drawings annotated the foam glass aggregate as Glavel, just calling out the product name. And it's a novel material. Not many people around here are used to seeing it. And it was not until very late in the bidding game and talking through the contract with one of these finalist GCs that it was clarified that no, this is not gravel. It is not a typo. It is a foam glass aggregate product that fulfills dual duties. And when that was recognized and finally executed, the GC fell in love, and they said they don't want to use any other product for sub-slab, just because they can bring their own site guys out, so they get to control the schedule a lot better. And it's one fell swoop for typically two trades that would be doing that work. So it's just great efficiency on their side.
There were many things learned in this project, and I'm sure folks have many questions. So we will wrap it up at that. This is our contact info, and I think Kim's also dropped it in the chat. So happy to take questions.
Awesome. Well, thank you so much. Excellent presentation and amazing project. And well, thanks for sharing all these like very detailed this detailed information and numbers and lessons learned with us. And I do have a ton of notes here, but I also know that there are a ton of really good questions. So I'll keep it short. One thing that stood out for me is really just kind of starting with the beginning, just the fact that this is an old bus yard or a brownfield site, because I feel like that is something that, there's so much potential in these sites and they keep coming up, whether they're bus yards or train yards or old factories. And the thing about those sites is that they are most likely very, very contaminated. So another really good point for building passive houses, because they are really shielding everything. I mean, of course, you have to do quite a bit of mitigation before you can even touch anything. But, you know, continuous ventilation, air sealing really, really helps with sites like that. And maybe maybe you can talk about that a little bit more later on, because I'm really curious about that, and also about, you know, coming up with this master plan, what that meant for you or for the architect in terms of restrictions and regulations and all of that. But yeah, before we get into all of these questions, we do have to take a minute to thank our wonderful sponsors.
Yeah, thanks, Ilka and Sarah and Rand. Really fantastic. This has been really inspiring. I do want to take a moment to thank the fine organizations that make all of our work at Passive House Accelerator possible. So a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Ingwe Architecture, Partel, Rockwell North America, and Zola Windows. And thank you to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Systems, and Source 2050. And thanks to our patron sponsors, Building Type, Brennan, Holstrom System, Inotech Windows and Doors, Lamelux, RDH Building Science, and Sanderson Sustainable Design. Big thank you to our sponsors.
Thanks, Zach. Thank you, sponsors. And thank you, Sarah and Rand and Julie. We are so lucky to have presentations like this. The amount of information you shared, the cutting edge things you've dealt with, piecing together haphazard codes to have some guidance forward on the backup system was nothing short of Herculean. And we just don't get learning like this without these kinds of events. So thank you for designing, building, and sharing it with the community today. So up first for our questions is Scott Derber. Scott, are you available to unmute and ask your question live? If not, I can ask it for you. Looks like you're here.
While we're waiting for Scott, Ilka, you had mentioned this contamination, and I'll just give a quick anecdote that, you know, Rand observed on site. It's in the middle of an active construction site on multiple sides of the project, and the ERVs were not performing very well pretty quickly, and I think folks were like wondering what was going on, went to check the filters, and they were already full. What was that? It was within a month, Rand. It was so fast.
Yeah, it was pretty quick.
Because they are doing their job, because there is dust on the site, and it really makes a difference. And so I think POA should be charging the neighbors for that first set of filters.
Yeah, and as Julie mentioned in the chat, this master plan did achieve a Phoenix Award for Excellent in Brownfield Development, and a Project of the Year award from the Brownfield Coalition in the Northeast. Our project also feeds into a LEED neighborhood development master plan. So the whole site is a neighborhood development. So with that comes heat island mitigation that we see through our rooftop terrace and our reflective roof. We have plenty of bike parking on site. Not only is that for the LEED neighborhood development certification, but it also is just standard practice in the city of Boston now by code.
And Dream did not do the plan. It was another architect that had
Right.
been many, many decades in the process. And we advocated, our site has beautiful native plantings that are very sustainable. And the lawn in front of the project is not our control. We tried very hard to prevent turf grass. Okay, questions.
Excellent. Well, thank you for trying to fight for the removal of lawn and wilding of that space. But it looks like Scott had to jump off. He was interested in the design decisions around the corridors, and if it could have been a single stair, single point of access instead of a double loaded corridor.
I think that's a really good question, and I think it's a question that I think is becoming more prevalent. You know, Seattle has done a really good job going with single stair point access blocks. We're discussing it in Massachusetts. There is a kind of discovery committee through our state legislature that's tackling it right now. But right now, we are not allowed to go over 3 floors and 4 units per floor with a single stair.
Thank you. Great answer to a good question. Next up is Martin Kropf. Martin, it looks like you're here. Would you like to unmute? If you aren't free to unmute, I can ask your question too, but we'd love to have you come on.
Sorry about that. Yeah, sure. I was just curious about how individuals were able to dial in their temperature, being that the ERVs were shared. I think it was 2 per floor. And, you know, the job of the ERV obviously is to keep the temperature level. But I think I got a response saying that there was an individual coil unit for each apartment. So maybe some clarification on that would be great. Thanks.
Yeah, so let's back up and talk about the 2 systems at work here. One is our ventilation. Our ERVs are taking in ambient exterior air and pumping it into our interior environments. What makes it so special is that it's pumping interior air out that has already been conditioned and exchanging that thermal energy in a little core inside of the ERV. And so the air coming in Boston, we get frigidly cold winters and decently warm interior air. And so if we're sending out air that's 68 degrees Fahrenheit and bringing in air that's 10 degrees Fahrenheit, we can bring that air up to roughly 40 to 50 degrees, depending on the efficiency of the ERV. So that's handling fresh air and ventilation. The other system is heating and cooling, which is where our variable refrigerant flow heat pumps up on the roof come in. Those are large to handle a lot of units at once. And then per floor, we have what's called a branch controller that handles the refrigerant going out to all of the individual units. That branch controller is sending either warm refrigerant or cool refrigerant, depending on how the residents set their thermostats. And then, as was mentioned, inside of those units, we have fan coil units that provide that heating and cooling.
Great, thank you. Just one quick one though, and this might be sort of the devil's advocate though. If you have, you know, a really cranky dweller who says, I like to have it really cold in my apartment, has it been looked at that their action would short circuit the collective ERV system?
It's not going to impact the whole system.
Okay.
Yeah, they can set temperatures. These are older folks and they like to have it warm in their apartment. I can speak from experience going into a few.
Yeah, and just to throw in there, one reason why we like to do central systems is because we have access to a master controller, like from our downtown Boston office. We can look at our Chicago properties, Florida properties, and we can see what temperatures people are setting. We try to do some limits. If it's a senior, you know, code requires us to provide like 68 degrees in the winter, which is not warm enough for most people. Right. So we have some limits that we set. And then if we have residents that complain that they want it cooler or hotter, we at least know when we change that might be something we want to watch in terms of humidity. So that's a big reason why we do central systems. And yeah, we know the refrigerant is, you know, hopefully we're going to get a good refrigerant at some point. But we just feel like VRF, we can size it better for our units. We like ducted systems. The cassettes we've had some real issues with, but you know, we use a master controller, and we can also see the ERVs, mostly what their operation is, not necessarily what temperature the air is that's coming in and out of those.
Thanks, Zach. Thanks, Kim. Great events. Next up, we've got Tom Phillips. Tom, are you with us? Would you like to ask your question? Give you a sec to unmute in case you are having trouble finding that button or remembering what your question was. Because you had a couple. The first one was power outages. How will the battery and essential services perform in extreme weather conditions? I'm not sure who that's directed to, so I'll let you guys arm wrestle for that one.
I did put an answer in the chat. there's no concerns of it operating in extreme temperature. And as Rand presented, probably right after the question, there's a portion of that battery that's allocated just for emergency power. We doubled what we needed for that. I think it's 90 minutes. So we can't touch that for any incentive programs or any of our resiliency.
Too bad. We want more incentives for all of that, and hopefully this project will create some legislation around it. All right, next question up is from Richard Martz. Richard, would you like to come on and ask your question?
Yeah, thanks for taking it. It was about the battery backup and whether it's a 3-phase power and able to provide both, obviously the emergency backup, but also like the peak load shedding. We looked at doing that a few years ago with a Tesla Powerwall, not the system you guys had. And we ran into some issue where it was ended up being one or the other. And I was trying to rack my memory and was trying to dig up my notes, but it was a few years back. So did you run any hiccups there?
This was one that I think Andy answered in the chat. Andy was actually instrumental in getting this battery designed and installed. He's with Revision Energy, and yes, it is a 3-phase system. I couldn't
we will do some load shedding as part of one of the demand response incentives that we are getting signed up for at the moment. We have to install some interval data collection meters that we don't have at the moment, but that's in the plan.
I have to ask, how aggressive is the time of use pricing or the multiplier for time of use pricing when you get into that super off-peak zone?
So what's interesting is a senior building, it's a lot less, right? There's not a big curve at certain times of the day. So when you're doing the load shedding, it's, it doesn't have the best payback, but we will be able to take advantage of the fact that it's an electric backup for that, as opposed to, fossil fuel.
Yeah, and so no one's leaving and going to work or going out as much, right? And then they also usually aren't driving as much, so you don't really have a lot of EVs sitting in and charging or hanging out as maybe potential
in Boston,
future batteries.
They keep sort of extending, demand charges are the most, like, used to be from like 6 to 8. Now it's like 4 to 9. So, the window is larger for when they can charge you more for the juice.
Excellent. That is great intel. Thank you so much. Up next after Richard is Sean Torbert. Over to you, Sean.
Sorry, can you hear me? Sorry, I'm on the train.
Yeah.
But I think hi, thank you and congratulations. Such a fantastic project. Julie, I think answered some of my incentive questions, but I was just curious, more specifically, if any of you could speak to what it was like navigating the Mass Save program, and then also was the per unit passive house incentive involved with that for multifamily?
Yeah, we got Mass Save has always been, they chase us, for handing out the money and at the different milestones. They participate in an analysis of a feasibility study that's done. That's basically the first shot at the WUFI model. And so we got all the incentives for the modeling, for the feasibility study, for hitting the passive house certification. Mass EC also was doing a the passive house challenge, where they were trying to incentivize developers to build to passive house, just to sort of educate people in the market, which we seem to do on most of these. And so we received a grant for that. And then we also got a special grant from them just to help us offset the cost of the battery.
And Bear Craig left the room, but I threw a link in there to the program Julie was just talking about. It's a great design challenge. And thanks for that question. The next question is from someone who has left the room, but I had a similar question, so I'll jump in and ask for Scott Derber. Had you considered geothermal or thermal storage to lower operational cost and do more load shifting? And then I was even going to say, and create some preconditioning tanks for the domestic hot water.
And I do think Julie replied to that in the chat.
Oh, did she? I'm sorry, I missed
camera,
it.
no problem. Your camera just went out, Julie. POA was not interested in that. They've had some difficulty in the past with geothermal in regard to subsurface conditions, and so I think that's something that wasn't on the table in this particular project.
Excellent.
Yeah,
Great.
in the space for the preconditioning tanks, you know, the COP on the heat pump hot water heaters is really good. So, and I don't know where we would have put those tanks, but you know, I love that. I love that product.
Great, thank you. Tom Phillips, we're back to your third question, I think. Would you like to come back on? If not, I'm going to just jump straight to Mario. Mario Correa, are you with us? Would you
Hey,
like
good
to
morning, everybody. Well, afternoon in some places, right?
Yep.
First off, fantastic. So were you limited? Were you limited? I mean, I was going to ask about being on the grid. I live in an apartment building here where my landlord had to fight the state Supreme Court for him to build as big a PV system as he could. It was kind of like in that between period back in the, I think, early 2000s. So were you limited as to the amount of PV that you could use, or did you go for the most footprint that you could and then base your backup on that? So for when the higher usage and you're not producing as much, you can store as much as you can. And then obviously I was going to ask about the emergency connection to the utilities, but obviously you have to, because you're obviously shedding part of your production over to the utilities, which is fantastic. I mean, you're producing enough, so I just figured I'd ask those two questions. If you know,
On the size of the PV, typically we want to maximize. We are not maximized at this site, so there could be a chance to add some more at some point. You do have to have, you know, the right capacity for your building to put juice in the grid. We won't probably ever do that because the array is not that big. So that's for that question, but I know that there are some issues on apartment and condo buildings about how you allocate to different apartments, or even just shed the, you know, the owner's loads. So that can get sort of tricky. And the other question, yes.
was you're obviously producing enough to hold you over through the night, you know, say when you're not producing. So I think that's basically and kudos to all of you. Really, that's fantastic. This is a really cool project to be informed about. So good job.
Thanks. The only real limit that we have on the size of the PV is making sure that there is walking space for fire folks to go up on the roof and do their thing in the case of a fire.
Well, thank you very much.
Thank you, Mario. And I found Tom Phillips' other question, and he's put some information in the chat as well, but it was regarding the AIA standard of care for climate change. And he was asking, did you assess the risks for indoor overheating with regard to the climate change?
Not formally. I mean, Rand, did we get into this a little bit more in the weeds?
Yeah, I don't. So we've been really lucky to work with one of POA's frequent partners, Building Evolution Corp, who do the WWOOFie modeling and a lot of the passive house work that we're both trained passive house professionals, but it's really great to get that second set of eyes on things and also get that diverse experience that they've had. And we talked a little bit about future climate situations and the potential for heating, like a higher heat environment, especially in the summers. But I think one of the great things about a passive house building is that it is just resilient. Whatever you're doing inside, you're so slowly transferring that heat energy through the wall that as long as we're right sizing our systems and everything, we're not going to be as concerned with overheating internally.
Great. And this is the 5-minute warning, maybe 7-minute warning. We're coming up against time. So if you have to go, we understand, but please stick around if you can. I will say for that overheating, just doing the dehumidification the way you did, I think takes a lot of that risk away. You know, we've all seen the comfort calculators out there, and humidity is a big part of that comfort. So I'm losing track of who is next. Who is next? It is Nandini Prasad. I hope I'm saying your name right. Would you like to come on and ask your question?
It looks like they've left, Shannon.
Okay, wow. She was curious to know who monitors the batteries, and do the solar panels have a heater for snow melt?
They
I can
do not
answer
have
the-
a heater. Yeah, go ahead.
Yeah, the PV does not have a heater. They don't have resistance heat up there to melt the snow. And Julie can correct me if I'm wrong, but I believe that Revision is the battery monitoring service and maintenance.
Yeah, I threw a link in the chat for them. That dashboard was sweet.
They keep up with the array. The battery is by the battery manufacturer. And we looked at so many, I can't remember where we landed,
They're
but
current storage systems, they're called now.
Yep. And yeah, so it's well monitored, which was a stipulation by the fire department.
Perfect, thanks, Julie. And next up, we have, I don't know how to say, D-Bask. Is D-Bask here? Looks like you are. Would you like to unmute and ask your question?
Hi, thank you for taking the time. It was a great lecture. You answered the question. I was concerned about what are you doing for reducing humidity in the apartment, and I think you answered it in the comments.
Yeah, and Julie, you did mention it was a venticity system too. Thank you. Thank you for coming on. How about George? George Ostro in Brooklyn? Are you with us? Looks like you're here still. George Love? Ah, there's two Georges. All right, George Love, you're still here. Would you like to come on and ask your question before we run out of time?
Well, I was just wondering if Berto played a factor at all in the owner's decision to go with all electric. I used to do financial analysis for Berto studies, and in a lot of cases I found it was still mostly the Berto alternative compliance fees didn't necessarily provide the right amount of financial motivation to get owners to switch, but I was curious if you did any of that analysis.
So we look at that a lot and often. We have a couple of historic buildings. I think I put this in the chat. We have a couple of historic buildings that we have real limited opportunities to improve their performance. And so in Boston, there's an opportunity to do some averaging. And so all the new construction we do in Boston is passive house. So we sort of feel like that will balance when we average those out. But one of those historic buildings is likely to hit a threshold in 2030 in terms of fines for not, for emissions.
And for folks not in the Massachusetts area, Berto's a building emissions reporting disclosure ordinance, and it's basically going to start fining owners that are emitting too much, period, at its 15 units or 20,000 square feet or above. So this building it's interesting because the brand new construction will be compliant, we'll have to comply to that, but we're going to be good.
Perfect, thank you. All right. Looks like Eric Zeiss is still here. Eric, would you like to come on and ask a question?
I think you may have answered a good part of it in the chat, but I was just interested. I've worked on a couple of brownfield sites, And it's usually a lot of work to get to the point where you can actually do anything on top of or remove the stuff that you need to in order to start working on anything. I was just wondering how intensive that turned out to be.
Fortunately, we did not have to do it, but it was very intensive. And like you said, since it's housing going on this, which will be the majority of the buildings will have some component of housing. It was really critical that the contaminants were gone.
And did that end up increasing the site cost quite a bit?
There's a community development corporation that put in an RFP with the city of Boston for the site. And I think they were given some incentive dollars to do the cleanup as part of the acquisition of the property. So it didn't affect our costs, but the city wanted this to happen, so the city invested in that.
And one of the cool things that we were able to do on this project specifically was, as Sarah was describing, that earth bermed wall at the back. We knew that we were going to have some cut on our site that we could then use as fill on the back to berm. And we ended up using all of the other cut from buildings that had already gone in to fill that as well. So just by that one like really elegant move of doing that earth berm and mediating a pretty big change in grade, we were able to bring site costs for the overall master plan down.
A lot of synergism. Thank you so much for a wonderful presentation.
Can I just ask a follow-up question to that? Did you have to go through more like indoor air quality measurements because it was a contaminated site? Or was that all kind of mitigated and then you basically started from, basically as a new building?
Yeah, you have to achieve a certain, and I can't remember the terminology, but you have to get to a certain level of safety. So I imagine that if you did any measurements now at this site, soil, air, water, you wouldn't find any contaminants.
Great, thanks, Julie. All right, we have come up to our last question with Eric Reinhardt. Eric, would you like to come on and ask your question?
Sure. I was just curious about regular maintenance of the HVAC and ERVs. Is it all external to the units, or do you have to make regular visits into the units to keep things running properly?
Yeah, great question.
We have filters. Yeah, we have filters in the kitchen and hopefully the bathroom that have to be replaced. Grease in the kitchen and just a regular air filter in the bathroom. The ERVs, they're in the hallways, so there's a ceiling panel that comes off so they can access the panel on the ERV to change filters, and the VRF equipment on the roof is obviously accessed, from the roof.
Thanks much. Great project. I really enjoyed the tour. Thanks, guys.
Thanks, Eric. Thanks for your great question. I can't wait to tour this project. And Sarah, Rand, Julie, Ilka, Kim, thanks in the background. Thanks to everybody for coming and for staying for the final 15. I think we're going to hit a lot of views on this project. I really appreciate you guys taking the time to be with us today.
Wonderful. Thanks for having us.
Yeah, thanks Passive House Accelerator for having us.
Bye, everybody. See you next time.